Welcome to Kenton's videos. Enjoy the video.
You start by confirming the data suits a semi-log, exponential growth, or multiplicative changes. First, set the x-axis linear and the y-axis logarithmic, choosing base 10 or e depending on convention. Once done, scale the axes so tick marks represent equal ratios, not equal differences, and label units clearly. Make sure to include a light grid to read values. This step forces correct visual interpretation, so don't skip base and labeling. Those determine how slopes map to rates. You now plot the data. Either transform y into its logarithm before plotting or place raw y on a log axis directly. Once done, add points and connect them with lines to highlight trends, but avoid overfitting with high-degree curves. Make sure to examine slope. On a semi-log, a straight line means constant percentage change. Steeper slope equals faster exponential growth. Use transitional phrases to compare segments and calculate growth rate from slope when you need precise percent per time figures. You finish by annotating important points, adding a legend, and if available, confidence bands to show uncertainty. Once done, check axis limits so small but valid values don't disappear near zero, and adjust limits or add inset plots as needed. Make sure to inspect outliers and decide whether they reflect errors or real phenomena. If something goes wrong, like 0 or negative y values, use an offset, filter, or choose a different plot type, because logarithms cannot accept non-positive values and will break the display.
Thanks for watching. Consider subscribing if we helped you.